Okay, the last three problems on the annuities worksheet. And a couple of these are definitely some of the hardest that are on here. First one, number 4. This is a pretty realistic problem. Local school district has issued bonds to pay for the construction of a new elementary school. District wishes to establish a sinking fund in order to retire its bonds when they reach maturity. Some of the bonds mature in 10 years, the other in 15. Mature, when a bond matures, that just means that it has to be paid off. So the sinking fund is a way for the district to set aside funds so that when the bonds come to maturity, when they have to be paid off, they actually have the money to pay it off. If they're not left just standing there, not able to do that. So that's why they established the sinking fund. So they figure out that they'll need $5 million in 10 years and $10 million in 15 years to retire the bonds. And they're going to make payments to the sinking fund at the end of each month that accrue interest at 6% annual interest rate compounded monthly. How much money should the district pay to the fund each month? Okay, what makes this problem a little more difficult than some of the other annuities problems we've done is there's two annuities, there's two payments that are due that we have to take back in time. So you have to look at them and put them together. So let's see here. So here's the timeline. This is in months, 120 months, 180 months. 5 million here, 10 million here. So take each of those back in time, and remember you can do that by dividing by 1 plus I to the n. Each year that you go back, you divide by 1 plus I. Each year you go forward, multiply by 1 plus I. So the 5 million has to be divided by 1.005 to the 120. 10 million has to be divided by 1.005 to the 180. Those give us the present values of each of those. Now, when you add those up, the 5 million is about 2.7 million now. The 10 million is a little over 4 million now. So you add those up, that means the total present value of each of those future financial obligations is about 6.8 million. So what the district has to do is figure out a 15-year annuity that has this present value. So the present value is going to be the 6.8 million. And we know that it's going to be 180. That's the number of payments we're going to make. They're all going to be the same. And we have to find what that is, find R. And we know that I is 0.005. Okay, so we've done this before. So you plug each of those in. You invert this, bring it to the other side, plug it into the calculator, and you get R is 57,576.25. Now what I wanted to do was, beyond just getting this, I want to show you that this does work. Because we're going to see what happens over those 15 years. Because it's not quite clear, that that's exactly the right amount. And why is that the right amount? So let's see what actually happens. For the first 10 years, and this is the amount each month. For the first 10 years, you accumulate a future value. You don't have to pay anything out. There's no bonds that have matured yet. So the future value, you plug into the future value formula, and for 120 months, this is what you end up having, 9.4 something million dollars. So that's how much is in that account at the end of the 10 years. But after 10 years, the 5 million goes bye-bye, right? Because those bonds have to be paid off, they matured. So immediately you lose $5 million, and you go down to this almost $4.5 million. So that's how much you have then right at 10 years. Let me just leave that back up there for a second. Okay, and now we're moving on. Okay, so at 10 years, now we're looking at these last 60 months, these last 5 years. We've got that $4.5 million or so. That is going to accrue interest over the next 5 years. So we have to find its future value. And when you do that, if you plug that in, again, none of this is anything you have to do to figure out the problem. We're just seeing what actually happens. So that 4.5 million, if you bring it forward 5 years, this is just the single payment future value formula. 1 plus I to the n times p. And that turns out that that's really going to be worth, it's going to accumulate to just under $6 million. So if you didn't put any more things into the sinking fund in these 5 years, nothing more, you just left that there, you'd have almost $6 million. Of course, you need $10 million. That wouldn't be enough to pay off the bonds. So you need to continue the payments. So the remaining sinking fund payments forms a 5-year annuity. What's the future value of that annuity? What do those accumulate to? Use the formula again with 60 instead of 120. And look there, it's just over $4 million. In fact, if you add the accumulated value of that 4.5 million over those 5 years, plus the future value of the 5-year annuity that's going into the sinking fund the last 5 years, look at these two numbers. Add them up, you'll get $10 million. Well, it's off by 13 cents, which is insignificant. So you can see there, what's actually going in, coming out of the account of the district and its sinking fund to pay off those bonds. So that was an interesting problem. Number 5. You had won the lottery. Okay, so lotteries, you have two choices a lot of the time. You can take everything in one lump sum, or you can take it over a number of years. Of course, if you take it in a lump sum, they give you less money. So why do they give you less money? Well, it has the time value of money, right? So you have two options here. You have the option to receive 4.8 million at the end of each year for 25 years. So nominally, if you just add or multiply 4.8 times 25, that's 120 million. Okay. Or you can receive a lump sum of 83.6 million today. So a lot of people will say, well, I don't quite understand. They give it to you over the 25 years. Why? It's only fair to say, well, we'll give you the 120 million today. Well, if you understand time value of money, you understand why that's not fair. Because if they pay it out over the 25 years, there's an opportunity cost that they could invest it and make a lot more money. So 83.6 million today, you have to give a lump sum less up front than if you're paying it out over the number of years. So let's assume you could invest money at 3.2% effective annual rate. If you could do that, then which option would be better? Okay, and we're, again, assume you live the whole 25 years and ignore the fact that most people probably wouldn't care one way or the other. So let's look at these two. Okay, 4.8 million at the end of each year for 25 years. This is an annuity. What we have to do is figure out the present value. What's the present value of all those future payments? And then we'll compare that to the 83.6 million. That's really the problem is you want to compare the present values of the two payment streams. One of them is just a single payment, the other is a payment stream. But you compare the present value. So the present value, so this is the present value of an annuity formula. You notice there's a lot of situations here where we're using present or future value of an annuity formula, but it doesn't quite fit the way the book looks at it as far as they call them increasing and decreasing annuities, which I hate that terminology because it's not standard usage. But so this is not really the sense that the book was talking about present value of annuities, but it makes sense because that's really how you want to compare these two. Okay, so plug in. This is the effective rate, so actually there's no compounding here. It's just I gave it as an effective rate, so just use that as I. If you plug it into the formula, it's 81.8. That is less than the 83.6. So you should take the lump sum. Okay. the last problem, number 6. This one's kind of involved as well, and kind of realistic too, I think. Greta wants to retire in 18 years. Okay. At that time, she wants to withdraw $18,000 at the end of each 6 months for 20 years for retirement, and also $15,000 at the end of each 6 months for 5 years to give her newly born granddaughter. So just had a granddaughter, and setting up a college fund and wants a retirement fund. Assume money can be deposited in an account paying 7.5% annual rate compounded semi-annually, so the same time period that the payments are going to go in and come out. How much should be deposited at the end of each 6-month period over the next 18 years in order to accumulate a balance that will provide both for the retirement and the college fund? So this is one of those ones that's 2 problems in one. You have to figure out the first thing here, instead of figuring out the future value like before, you have to figure out the present value of what you need to come up with in 18 years. And then we'll figure out the rent payment that'll give us the right annuity to come up with that as a future value. Okay, so let's look at this. Okay, first, figure out how much Greta needs in 18 years. So we're already in the future. The granddaughter is in college, starting college. Retirement started. So these $18,000 over the 20 years forms one annuity. Okay? And that's the present value of it. So I'll let you look at that. So you should understand by now where this formula is coming in. It's similar to the previous problem we just did. But we also have these $15,000 a year, or sorry, $15,000 every 6 months for 5 years. And that's for the college, and that has a certain present value. Not as much as the retirement, but has a present value. The sum of those two, that's how much we need to have at the moment retirement and college starts. So the sum of those two, that's the $493,109.63. So that's how much we need then. Okay, so that now becomes a future value. And now we're looking at the next 18 years. So we've forget about the future. After retirement and college, how do we get that much? So over the next 18 years. Okay, so we have payments of R at the end of each 6-month period. And we're looking at this formula, we're solving for R. So this is the future value that we need to get, 0.0375. So I think that was because it was, let's see, yeah, 7.5%. So 1/2 of 7.5% is going to be 3 3/4% to the 36 minus 1 over I. And if you solve this equation for R, $6,691.80. Now, keep in mind, that's every 6 months, the end of every 6-month period. That's not monthly, that's every 6 months. So, doesn't seem like an unreasonable amount. I think this is a pretty realistic problem as far as the numbers involved. So, anyway, you might want to go back through and listen to this explanation again, because there's a number of different steps, and you really have to think through why we have the 2 annuities, the present values. We have to add those up, and then that becomes a new future annuity for another problem where you're solving for the rent, and that's how much she has to put away every 6 months. Okay. This PDF is available on Blackboard online. If you go, you can print this out as well, so you can have that in your notes to look at. And I'll see you next week.